Before we really dive into the fundamentals of cryptography, let's briefly pause and sort out our understanding of the subject cryptography itself. Looking into academia and specialized literature, one often comes across the three words cryptology, cryptography, and cryptanalysis. Sometimes these words are used side by side, sometimes these words seem to be used interchangeably. Common to all these words is that they root back all the way into ancient Greek, with cryptos meaning hidden and secret. Looking now at the word cryptography, graphein roots back to Greek as well for the word writing, and it's then also based on these Greek roots that the understanding of cryptography is for cryptography to be the subject that deals with the constructions of systems that allow for secret writing, or a bit more generally expressed, for systems that allow for secure communication to take place. Cryptanalysis, on the other hand, is then the subject that analyzes these systems constructed by cryptography for their strength in terms of security. And finally, cryptology is then the general subject for the study of systems allowing for secure communication, which involves both the constructive side with cryptography as well as the analytical side with cryptanalysis. This course itself also has elements of both cryptography as well as cryptanalysis. For each of the cryptographic primitives we will get to know during this course, we will also have a look at how this primitive is constructed, but always also have a look at the security notion and the security strength associated with this cryptographic primitive. With this, we could say that this is actually a course in cryptology, but given that we will spend the bulk of the course looking at how cryptographic primitives are constructed, I decided to name this course Fundamental Cryptography nevertheless. Cryptography, as the subject that constructs systems allowing for secure communication, evolves equally much like information security in general around a certain set of security goals. The classic security goals of information security, or famously known as the CIA triple of security goals, where the C in CIA stands for confidentiality, where the I in CIA stands for integrity, and where the A in CIA stands for availability. Confidentiality is then the security goal demanding that information in a system is only accessible to an authorized party. Integrity is the security goal demanding that the correctness and completeness of information can be verified. And availability is the security goal demanding that information is always available when needed. As you can see, I commented availability with out of reach for cryptography. I invite you to pause and have a think about as to why the security goal of availability may be out of reach for cryptography. The security goal of availability is out of reach for cryptography, as cryptography is an abstract subject very close to mathematics. The ideas of cryptography are coded up into cryptographic primitives such as encryption. These cryptographic primitives are then made use of in technical protocols such as TLS, the Transport Layer Security Protocol, and these technical protocols then make up technical systems that ultimately run on physical machines. From this, it can be seen that if information in an information technological system needs to be available, then this is mostly the responsibility of an outer layer, with cryptography residing towards the more inner core of the system. Due to availability as a security goal being out of reach for cryptography, cryptography as a subject has its own set of 4 classic security goals. Confidentiality and integrity as security goals are the same security goals as the security goals in information security, but instead of the security goal of availability, Cryptography now has the two additional security goals, authenticity and non-repudiation. Authenticity as a security goal demands that in a system with authenticity, the source of information can always be verified by the receiving party. Non-repudiation as a security goal then demands that in a system with non-repudiation, the source of information can not only be verified by the receiving party, but that the source of information can be verified by any third party. Now, it's absolutely fine if at this point the meaning of each of these security goals is not entirely clear yet, as this course is essentially a course about fundamental cryptography related to these four security goals, and we will have enough time throughout this course to develop a good intuitive understanding about each of these four security goals.